Hello everyone, welcome to another episode of Hazardous Safety. Today I've got on the podcast Nigel Cann. So Nigel, would you like to introduce yourself?
Yeah, hi Travis. Thanks for that. Nigel Cann from ARUP as a process safety specialist for our team, sort of covering lots of process safety around Australia and in the Pacific region in particular, but also with some global responsibilities as well.
So let's go into your professional career. So let's go back to when you were studying university. One of the questions that we always start with our guests is, did you ever envisage yourself when you were in university to be in the role and position that you are right now, and or what were you studying for, and how did your journey start?
Okay. Did I envisage did I be here now? No. In the short answer is no. I'm not sure in the early 80s that process safety was really specifically a thing, and certainly we never studied process safety in any of the degree that I did in chemical and materials engineering. So let's start there. I did chemical and materials engineering at Auckland University, and that degree was originally focused around getting process engineers involved in the materials heavy aspects in the New Zealand economy as it existed in the late 70s, early 80s, particularly around the aluminium and steel industries. As it evolved, some of the fundamental materials stuff I had a particular liking to, and so I went and ultimately worked with New Zealand Steel. I'd sort of made pretty good close contacts while I was at university with the people at New Zealand Steel, and they offered me a job post graduation. So my original work was really in the steel making area.
Then, because we've had a couple of other guests who have been process safety engineers, and they've all said the same thing, that it wasn't really a discipline. So when did you see the transition from being a chemical engineer into process safety? Like when did that happen? Was that just something that became more of an interest and then evolved into it, or you saw an opportunity to take that shift into it?
No, it was a lot more organic than that. So in the steel industry, I worked through technical roles, both internally within the various operations within steel making. Ultimately ended up in a position where I was doing advice to external clients. And then I started moving into the management realm. So did supervision of the galvanizing operations. That led into being a customer client liaison for a major engineering project within that department. Then I sort of took over the frontline management responsibilities for that. Moved to Australia when BHP took over New Zealand Steel, again in the galvanizing area, at which point I decided there was probably not much of a future for the overall steel industry. And so I started looking elsewhere. There was a job advertised as a PVC plant manager, which when I looked at the advertisement said, well, if there was an advertisement written for anyone, then this was it. And so I joined Australian Vinyls as a PVC plant manager for one of their two sites, which was a joint venture. In unfortunate circumstances, there were two fairly significant incidents in the first 6 months of when I arrived. One which essentially showed a series of degradations through management of change over a 20-year period, which ultimately led to that incident. And the second one was more a permit to work system failing, and there's some lessons to be learned out of that. And this all happened, literally my transfer between those two jobs occurred during the Longford gas plant crisis.
Oof.
I was shutting down a galvanizing plant in Hastings because we didn't have any gas to fire up the furnaces, and moved to Australian Vinyls, where we had to work out how we could come up with an emergency firing for our, got to think of the right term. Essentially, geez, I hate it when things just disappear out of your head like that. So the tail gas needed to be afterburned to make sure that we didn't have dioxins coming out of the system. So the very last little bit of the vinyl, when it gets recovered, there's a very small percent or very small parts per million sort of level, which then has to go through a thermal process to be degraded so you don't produce dioxins. And we needed that to operate to be able to process the tail gas, because I think there was, out of the 6 autoclaves that we had in operation at the time it shut down, I think 2 or 3 were in the middle of reactions at the time. So there was vinyl which needed to be recovered out of that system before they could make the plant safe, and they needed to actually have that thermal oxidizer operating to be able to do that recovery. And so there was a mad rush around to change it from natural gas to LPG.
And then you'd also have to figure out the balancing of that with the changeover as well.
Yeah.
That would have created a whole knock-on effect with all of your instrumentation, your calibration of your plant.
Yeah, all that. So by the time they'd got the LPG cylinders actually installed and all the system ready, effectively they were about to start the commissioning when the gas supply came back online. So we switched back to the natural gas and managed to recover. There was other potential complications in the way the process was, but fortunately we didn't. We managed to avoid any of those things happening.
So you've seen process safety like the term and now the discipline that we have today. You've been able to be one of the you've seen it through its infancy into like a fully fledged discipline with a very stringent framework, and we have methodologies, we have process safety fundamentals and pillars. What was some of the learnings that you were able to identify early in on the piece that have seen the discipline move in the right direction and move quite rapidly?
Yeah. Okay. So let's go back to, I talked about the fact that when I started in the plant, we had 2 incidents 6 months in. One of those incidents saw a release of about 3.5 tons of vinyl to the atmosphere. And as part of our strategy with the regulators, we offered to be an exemplar safety case for what was then the draft regulations that came out of the Longford gas plant crisis. Gas plant event, I should say. So it was at that point that I guess it was about developing safety cases and about how that process would actually look, and trying to learn, particularly from the UK, where safety case regimes have been around for quite a while with SEMA and COMA. Just trying to think, COMA probably hadn't quite come into being at that particular point in time. So we had actually offered to be the exemplar. WorkSafe wanted to work with us because they wanted to look at how they started managing their operations for their major hazard facilities unit, as it was at that stage as well. And that was part of the quid pro quo. And so the idea was we would establish a safety case ahead of time, or ahead of the main regulations coming in, and then we could use those lessons learned to work with WorkSafe as we went around doing roadshows and things to the other major hazard facilities about, these are the sort of things that you need to think about, these are some of the processes you might want to use. So having pulled together that exemplar program, I went to the UK in the early 2000s, and I can't remember exactly when it was, but there was a hazards conference in Manchester, and there was also a safety case conference in London put on by DNV, I think, that sort of was around the same time. So I attended both of those conferences, and it gave me a chance to also go and visit some other PVC manufacturers in in the UK and Europe through relationships that our company had with them. And that was when I really started picking up on bow ties. Bow ties at that stage were sort of, they were a thought piece, I think would be the best description of it at the time, but I did see the potential for them to actually being something that would be quite useful for communicating what the relationships between the hazards and the controls that you had. And they really were just a thought bubble. They were nicely laid out, and they sort of just talked about hazards and control measures or barriers, and how you actually then manufactured and did something was something that we had to sort of learn on the fly.
Was it more of a case that you'd have like the technical application of it being, your thesis, and then you'd see, figure one would be a bow tie, and that would just be like your high level overview, and then it would just get into another, 600 page or a 600 like word blurb on it, and then it would go on to another isolated graph. Is that like how it all started?
No, it didn't, because fortunately, I guess we'd seen the vision of what the outcome looked like. And I had a person that was working, we'd employed DNV to help us with the process. And so I had a dedicated person with me, and he was a relatively young engineer as well. And he, in the same time as I was overseas going to these conferences and stuff and had been exposed to it, DNV had exposed him to it as well. So we came together with both talking about this potential possibility. And as it turned out, the pair of us worked, had a pretty good synergistic relationship. I think the outputs that we produced in producing that first exemplar safety case far exceeded anyone's expectations. We just collectively could work really well together. So anyway, so sort of having that vision of what the output could look like and explain what the incidents were meant that we sort of initially devised a spreadsheet to work through a HazID process to collect the information. And then that started to evolve into something where we started to see the relationships between, we almost called them interim hazards. So you might have root cause hazards on one side, and then you have some barriers, and then some of those things would come together, and we could actually start to see how those relationships existed, and we could actually start planning in the workshops how to deal with that. And then that led to very systematic ways of developing the bow ties. So out of that came a database that we developed, which actually made that whole system a lot easier. And that database really became almost like a pseudo bow tie in the way it developed. But the bow ties themselves weren't automated. As it turned out, DNV then picked up on that, and they created their own system to automatically deal with it.
Was it in its infancy stage? Was it also was it a hard sell to upper management? Because the whole premise of process safety is creating interlocks within your process so that it's tangibly safer than what it is. But when you put those constraints in at the beginning of it, we're talking like 20 years ago, 15 years ago, there weren't case studies to rely on. There wasn't, okay, well, if you do X, Y, Z, these are going to be your return that we can tangibly see today. We have that time horizon of incidents, we have that time horizons of technology, we have that time horizons of evidence to be able to showcase that to management so that there is an ROI on that. So how did you bridge that gap?
Well, I don't think it was actually that hard to sell. There was two. It goes back to those two incidents that we had. To sort of paint a bigger picture, the plant that I was managing, which was the Laverton PVC plant, had come out of the ICI Australia network. And it was the first plant that was built by ICI around the world after they discovered the link between angiocarcinoma and VCM was understood. And in fact, the plant they'd actually stalled and the actual construction of the plant while they had some of the major lead items, like some of the autoclaves and some of the steelwork and stuff, was actually physically on site, lying on the ground while ISO stalled and decided whether they're actually going to continue to manufacture it or not, or to construct the plant. So the plant itself had a lot of inherent safety features built into it. Trevor Kletz was in his heyday in control of things. And in fact, one of the biggest satisfactions I had in the safety case was finding some of the original notes that Trevor Kletz had actually produced around layouts and, keeping separation between the unloading areas and the storage areas and the reaction areas to maintain safe distances, and then being able to validate those with more up-to-date consequence modeling to show that, they were separated sufficiently so there wouldn't be any sort of domino effects between those areas. So the plant itself had a lot of fundamentals going for it. A lot of thought had been put into the selection of the operators. They were all highly educated or very very capable individuals that had been selected for the plant. So a lot of thought had actually gone in about how all those things happen. So the fact that we'd had 2 incidents inside 6 months, the management team who'd come out of that same ICI culture were concerned that, hey, things weren't quite as good as you would have anticipated for what should have been a showcase plant. So they wanted to put the plant back on that pedestal. So it wasn't actually that hard to sell.
Wow. So it was more like because of those external factors that and because of the culture of the management team, as you said, it wasn't a hard sell. And so with that, we hear about culture a lot today, about a positive work culture, a supporting culture. How have you seen within your industry, particularly in process safety, how have you seen culture take a pivotal role with projects?
Yeah. The way that I've seen it, well, certainly the way that my thinking evolved while I was a plant manager, that operation, was that if you do have an intense focus on one of those, particularly in process safety, I think, if you understand all the links between the way engineering controls and both passive and non-passive controls, links with your safety system, links with the safety management system, if you understand all of those links and how they all fit together, it becomes clear that if you're trying to improve stepwise through, that you'll actually get the benefits. So we started to see that we were starting to get improvements in the maintenance performance. I changed a lot of the culture to, rather than being reactive maintenance, to be a planning type structure. And that had been something systematic I picked up from the early days of management improvements when I was in the steel industry. They were, at that stage, they weren't a cohesive sort of plan. They were things that I'd seen and made significant improvements in the way operations ran. And so I deployed those, and then I started to see that these things were all interlinked together. So as we started to improve performance around the maintenance activities, and we started to understand, say, things how relief valves got swapped in and out, and the testing that we started to instigate because of the safety case, we started to see how we could make improvements where we didn't have to maybe change things out quite as often as we needed to. How some of the other test routines that we had, never showed anything, so we could change the frequency that we were doing those tests, and then there was other ones that we had to increase the frequency. And all of those things came together that we actually had a much better maintenance performance. And so there was we started to see those ROI things that you talked about started to manifest themselves as maintenance changed completely from being reactive to being almost totally planned. The reactive stuff became literally, the maintenance manager would walk into the shift control room and they'd have a stand-up meeting for 5 minutes to deal with the one or two things that need to be dealt with straight away. It literally, the afternoon became when we actually did all of our maintenance reviews and planning for the next day. It was all about what they're going to be doing tomorrow, later this week, the rest of the week. When was the next short shutdown coming down up and that sort of thing. So that's how they are. That's how the maintenance meetings became. But I mean, that took a whole period of time for that sort of stuff to happen.
That would have taken a lot of pressure off the team as well, because they're going into a plant. They understand the boundaries of the plant. They understand that what they're required to do. They understand. So if you've moved through proactive measures, if you've moved that maintenance cycle forward, so that, as you've said, all of your reactionary items are end of life equipment. Probably you would have had like some piece of kit go into a failed state. It happens, but if they're few and far between, the morale of your team's much higher, because they're not having to always be in that constant reactionary mode, like get this done, pressure on them. And so did you find that the morale of your team was also higher as well, and that you had a lot better retention of your staff?
Well, retention for us was not an issue, to be honest. We had long-term staff. It really, So the facility was a good facility. The guys were well paid. Retention was not an issue. I mean, if there was an issue, it was the fact that we weren't turning over enough people often enough to get new blood into the business, and that was an issue. I mean, I talked about earlier about how people had been specifically selected for the facility, and they were, and they all, everyone was aligned about what the strategies were and what they needed to do things. So turnover itself was not an issue, and it essentially, because things became so planned, guys who were coming to retirement didn't need to be replaced because we weren't doing that reactive sort of type stuff. I mean, that's where we saw the tangible benefit come out the tail end of it, is there was a number of people who retired and we just never replaced those positions because we didn't need them.
That's fantastic. So let's move on. The learnings that you took from all of that body of work, being that plant manager, moving over from the steel industries into the vinyl industries, into your current role at Arup and the positions that you have there. So can you talk us through that segment of your life, and then we can move into renewables, about the global skill development and those kind of larger concepts.
Okay. So the transfer, so having gone through those management things, being the general manager of operations, I brought 2 ICs in. One of the major things that when I had arrived at the plant to be sorted out was actually updating the control system. And from my early days in steel industry, I did have a control system background. I'd spent time physically in the steel plant as a control engineer for a short period of time as a software engineer writing stuff. And fortunately, the plant itself had exactly the same control system, had a Taylor-based system, which was now part of ABB by that stage. And that system needed to be upgraded. And they'd had a program in place, which was falling to pieces. They'd gone to a Foxborough system, which had been the computer that was used by our sister plant in the JV, which got closed down as a result of safety case development. And then that project was failing. Basically, Foxborough were not delivering what was promised. And so I basically come offline to try and get that whole process sorted out, and eventually went back to market. And we went back to ABB, changing things out. So my transition had effectively been in that whole control system space. So once that project was up and running, the plant was recommissioned, I basically then moved out in 2008 with the vision of I'd set up my own process safety company, piggyback off the fact that New South Wales was supposed to be introducing legislation for safety cases. And that would be my opportunity to get into the market. So I went to some conferences, started to talk to the MHFs in New South Wales, and then of course the world financial crisis occurred in late 2008. Everything got put on hold. The government didn't bring in their major hazard facilities regulations in New South Wales. People stopped employing people. I've been in negotiations to maybe help some companies out with process safety. That all sort of fell apart. But while I've been going through that process, I'd been talking to GHD, which had bought part of the DMV, or had bought DMV's processing capabilities at that stage. And I'd gone to them to be able to maybe do some consequence modelling if I was doing consulting with companies. And they'd said at the time, well, Nigel, we're quite prepared to work with you, do these things. I mean, we're even prepared to bring you on as a sub-consultant, or if you want a job, come and talk to us. And my wife was getting nervous about the whole thing. She said, if they still got that job offer on the table, go for it. So I ended up consulting, doing process safety stuff with GHD for 2 years. And then ARUP tapped me on the shoulder to come and work for them, and that was essentially because they had a role with the Commonwealth as being an approved assessor of safety cases, and so they needed someone that could come in and pick that up, because the person who'd sort of been leading that process was going off to Mongolia to work with Rio Tinto on that big project in Mongolia. So that's how I ended up at ARUP. So it was sort of just a series of events and opportunities that had me working.
And how do you find your day-to-day role, like changing from obviously being on a plant, seeing results, seeing and being able to implement changes and implement safety cases, to then working with GHD, building safety cases, and then also now going from being a consultant with GHD to being with ARUP and working at a Commonwealth level? How do you see that?
Well, I mean, one of the reasons that I did the swap from GHD to ARUP was, I guess, I saw an opportunity to maybe bring some of the process safety disciplines and understanding to a wider context within the built environment. So bringing it into transport operations for road and rail, into buildings, sort of hadn't really envisaged where things would end up around hospitals and laboratories and data centers. Certainly hadn't seen the data center phenomenon in my mind, but I saw that as an opportunity to basically broaden out my skills and the influence that I might be able to have in that sort of environment. But also, I guess, being an approved assessor with the Commonwealth allowed me to be a little bit like a regulator, very much, and then being able to have a direct impact on the way that people actually had operations.
Mm-hmm.
So that sort of fed my appetite for getting out and seeing lots of different operations and interacting with lots of different people and what was going on. And that side of it was very positive. I guess the only downside of that is, as you sort of pointed out, is you actually don't see the implementation of all of your ideas. You're feeding and you're critiquing people, you're suggesting how they can improve stuff, but you're never actually involved in that longer term development, bedding things down within a safety management system, or in the way that people have, and I guess influencing people on a much longer term basis. And so, that's the part that I miss out of that whole management experience that I had previously.
But you do a fair bit, like with that space as well. If you're being able to showcase the learnings that you've had over your career and being to educate new operators or government departments or private sectors, do you, that sacrifice, for lack of a better word, because a lot, we're laughing about it, but there are a lot of process safety guys who have been there are a lot of high skilled operators who, if they leave, they don't want to leave their position because they feel connected to their team, connected to their plants, and that's just how the majority of them are. So I can see what you've done, and hearing it in your voice, not disappointment, but like hearing about how you miss seeing the implementation and miss seeing that. That's a real thing that a lot of people fail to recognize. So, do you feel that it's balanced at all?
I can't say that it's balanced. I mean, I guess my personality lends itself more to having, to wanting to have a bigger impact across a wider group of people. So I guess in the consulting role, you're spending a lot more time influencing a lot more people. I've always considered myself as Mr. 80%er. By the time I get 80% of the way through a project, I'm ready for the next one. And that final closeout is not me. And so as much as I miss not being able to see things through, I'm also not the person that's good at that sort of stuff. As a manager, I knew I had to have other people in my team that actually did all of that stuff, because I want to start thinking about what the next thing is and getting the next thing up and operating. So I think for me personally, this consulting role probably fits my personality a lot better.
I've heard it say, people say that the 80-20 rule is also, there's another portion to the 80-20 rule, that the last 20% is 80% of the effort as well.
Yeah, that's right. Yeah. That's probably true. Yeah.
so that's why I was laughing. I'm like, yeah, like just here it is, guys. Like here, it's only 20% to go, and your team's like, yeah, thanks, guys, great. Like now we're going to do the heavy lifting. So, well, that's amazing. Let's go into, so obviously working on a Commonwealth perspective and working with ARUP, you've been able to see a lot of emerging trends, particularly around sustainability, renewables, and the like. You also touched on data centers, which is like a completely different topic that we could unpack, because there's a lot of nuance around that, particularly around AI. I think Australia's going to play a very low part in that. We still have data centers to maintain, but that's an entirely different topic altogether. But if we just go into renewables and sustainables, have you seen that industry like change or evolve?
Well, yes, I have seen it evolve. I mean, I guess my first touchstone with it was really around doing risk assessments around BESS systems, and that was to meet requirements for New South Wales and their planning processes. And so the very first one was around some isolated solar farms that put in BESS systems just so that they knew they were going to have difficulty feeding the grid, and they needed to have something to be able to store the power. And that was before things started to get mandated that they needed to be able to sync up with the grid a lot better. And so that was the first part of it. And so there was a whole, I mean, when we first started, no one had done any sort of PHAs or final hazard assessments for these sorts of systems. And so really it was going back to fundamentals, how, what was the basis of safety for the BESS systems. We knew enough about them that despite all of the battery management system processes, that they still caught on fire. And when they did catch on fire, it was a fairly spectacular sort of type outcome. And we wanted to try and make sure that didn't cascade. The last thing you want on an isolated solar farm that's 200 kilometers away from anybody that could actually respond to anything
is thermal runoff.
Yeah. and you're ending up with country fire authorities and rural fire services and stuff that aren't going to be familiar with the technology, and really they can't do much about it anyway. So you had to be able to set up what separation distances you need between modules. How much is the owner actually prepared to lose? If they want to pack them closer together to save space, well, okay, you're going to lose more than one module. And so that became some fundamental risk assessment stuff that we used to go is, how much are you prepared to lose in the event that you have a worst case scenario?
Yeah.
And we had to apply, even things like thinking about bushfires and those sort of things. It was about, well, how do we get the right sort of separation? How much brown rock do you put down between the fence line and stuff? And we started to use things like explosive standards and that sort of thing to give us an idea about what they consider. And ultimately, what is now relatively standard is to have a 20-meter zone. That originally came from me assessing. That's what the code was around a magazine that stored 200 tons of explosives. It asked for 20 meters, and so that was what the basis of it became, because we had no other guidance that really could help us.
With that though, like, there's the work that you're doing, because you're going back to first principles all the time. It's showing the foresights, because there's a bit of a misconception particularly within Australia. A lot of people expect that they can find the answers in a standard. They can go to a standard, they can have a scenario, and they can go to a standard and open the standard, choose your own adventure, here's the outcome here. If we were in America, that's pretty much how it works, because they work in a prescriptive-based standard format. We work in a performance-based standard, so it's the onus is on the consultant to provide the solution that meets the fundamental safety application of the particular project and the unique environments and unique conditions for that particular project as well. Because we made that transition late 90s, it wasn't really sold to the industry, so you still have that tail off of information going out. Well, you go to a standard to it, and the standard's vague, and people are like, oh, well, the regulator should be doing something. So, no, no, the regulator's there to administer the law. Like, the standard's the standard. That's what we need you to meet. How you need to get there. You're an engineer. Put on your engineering hat. Go back to first principles and find it. So, talk more through. Was that strange for you to? Were you ever thinking, oh, well, I should be able to find something in a standard or a regulation? And when you started exploring, you came to that conclusion by yourself, or?
Well, I guess I've always been someone who maybe overly always wanted to find the answer themselves. I can still remember doing assignments at university and getting comments coming back saying, you could have just opened up the standard. You didn't have to develop this from first principles. But to me, that was about how I make sure that I understood what was going on. So to me, it's always been a little bit natural to head back. And so I guess, again, it comes back to the personality and who I am as a person. I probably fit being a little bit more bespoke and dealing with problems for the first time. I deal a lot. I mean, a lot of the work, some of the work that we do at ARUP, a lot of it's around planning, around people wanting to put in childcare centres and those sort of things around MHFs and pipelines and stuff. And all of that is all very bespoke, because it's all very dependent on the specific circumstances. Can you look at alternative solutions rather than just saying, no, you can't do this development because it's too close? Are there engineering solutions that you can apply? Do you fundamentally understand what the actual hazards are, what the worst case scenarios are going to be, and then can you actually engineer something? I'm probably not overly popular with the regulators in that respect, because I'm very much of the thinking that you can engineer a lot of those things.
You're allowed to,
and deal with it. And so I'll point that stuff out to people.
You're allowed to deviate from standards, like, as long as that's what another big misconception is. Like, you are able to deviate from standards as long as you meet the fundamental and practical safety implications. You can provide a first principle approach and a first principle method. You're allowed to do that. And as long as a certified engineer is going to sign off on it in that particular discipline, that is acceptable. And and if it's a construction site, if the building surveyor signs off on it as well, as it's been vetted through whoever needs to vet it, whether it's whether it's local council, whether it's a fire engineer, whether it's another safety engineer who peer reviews that particular solution, you're allowed to do that. I don't understand why people are so hesitant around the standard for 90% of it, the requirements and construction methods. You've got the BCA and you've got your technical standards for associated trades, wiring rules, mechanical services, plumbing standards, whatever it is. But there are, as you said, bespoke cases that require deviation for that to be feasible. So why not? Why not do it?
There is, in my mind, there is no reason why not. And there's always things that aren't covered by those requirements anyway. And as soon as you start dealing with, I guess, the more hazardous sort of type facilities, even the BCA doesn't have it. Basically say, well, you've got to go back and you've actually got to assess all of that stuff anyway.
They did take out, so with the transfer from the BCA to the NCC, the National Construction Code, they actually excluded the requirements for storage and handling of dangerous goods. It used to be included. It's no longer in there. It's a performance. It's a work health and safety requirement now. There's one thing that within the AS 1940 requirements that I don't really agree with, and that's the prescriptive requirements for fire rated walls. You've got your 240, 240, 240, 180, 180, 180, depending on volume size. I particularly don't agree with that, but with that, you can't. We've tried to, in previous projects, we've tried to get fire engineers engaged to reason with us, and we've done all the modelling, and it's still, they're like, no, because it's prescriptive, we can't deviate from it. I'm like, and that's one thing that we have not found someone that will work with us to be like, oh, you've got 10,000 litres, but you're never going to use it. Why do you need to have this? It's never going to be an issue because you've got all of these other integrated systems. If it does catch fire, it's going to explode and blow the hole out. So a 3-hour fire rated wall is just going to disintegrate. It's not going to smoulder for 3 hours, and you're going to blow that 3 kilometres down the road because of the amount of volume that you've got. But you've created a safer installation because you've got active ventilation, you've got suppression systems, you've got adequate detectors, you've got adequate fire suppression, you've got adequate dampeners, and all the other building things. So let's be reasonable here, guys. But no, they don't allow us to deviate. So all right, guys, you got to fill that wall now.
Yeah, I mean, there are certain things that we have done in the past because physically you can't do. I mean, things are getting far more integrated these days. So there's been issues where buildings have been put over the top of underground railway stations and stuff like that. You physically can't put the diesel storage tank at the lowest level in the building because that's a railway platform, and that is inherently unsafe. And so we've had to work through more fundamental principles and say, well, no, it's better to put it somewhere here. Okay, we meet the intent of not having it leak. So, you don't just have secondary containment, you have tertiary containment. And then you work through, well, what sort of fire rating do you need to have for the walls and do all that sort of stuff. So there are we sort of do other things to get across those sorts of issues. But yeah, to my mind, the development of data centers is a sort of a case in point as well. Just the amount of diesel these days that's actually been involved, and the fact lithium-ion batteries are coming along, and you've got the case where both diesel and lithium-ion batteries don't really fall very well under the Dangerous Goods Code, and certainly don't trigger the things in the past, although they are significant hazards. And so, both with New South Wales, effectively a lot of those centres are now of state significance that then effectively the planning minister's office is basically saying in the CEs and things, you've now got to do full risk assessments, even though you don't actually trigger it. And the same thing to some degree is now happening in Victoria, although they're using the dangerous goods regulations that trigger. And so you're ending up with the same conversations with the fire services. But this is actually a current thing at the moment about how you deal with the quantities of diesel being stored at these facilities, and also the lithium-ion batteries. And it literally is evolving as we speak.
Where we've been asked to comment on that in a couple of arenas. The conversation that where we lie with that is the rationale. The rationale is why diesel is left outside of scope is they go it's combustible because it's got a higher flash point. But then you've got the requirements for some of these new generators because they have to be like Euro 4 or Euro 5 compatible. They actually require to run on premium diesel. So the flash point's lower. It's not significantly lower, it's marginally lower. But then you've got that lower flash point. And then you've got the placement of the holding tanks for these generators. Then you've got urban radiation because some of them are on the top of buildings, some of them are. So you've got all of those consideration factors which no one models. So then it's a case that if you model that correctly, there could be a probability that that particular diesel will emit a flammable vapor. Will it explode? No, not necessarily, but like that's a risk assessment. That's our methodology that we utilise with it. Those are the considerations that you need to come to, and you need to be able to ascertain before you go down the path of okay, let's call it classification, and also with your recharging of your lithium ion. What about the runoff of the runoff of the charging gases, all that kind of stuff? Like, what are you doing with that? You're just sitting there going, oh, well, the charger has a port on it and that deals with it. Well, no, you've got a situation that you've elected for the use of a certain technology, and you have to now manage all of the parameters that come with that technology pack. So, and you can't expect that the magical box of tricks that you plug in will deal with it. You have to do your due diligence as well.
Yeah. So, I mean, I guess the two insights that I have around this area, specifically dealing with the data center issues, one is that really the fire services are really concerned about if it does catch on fire, they're not worried about the probability. If it does and they've got to fight the fire, can they do that? So if it's outside and they can gain access and they've got enough hydrants and they've got enough foam and all that sort of thing, then they're largely appeased by it. It's when things start to get constrained, which sometimes they can be around data centers. You know, we've had data center designs where the diesel is sort of half underneath the building or actually inside the building. And those things then become much more of a concern by the fire services and about how they would actually access them and how they would deal with a large event. And so you've got to be then quite specific and do very specific fire safety studies and deal with very specific treatment opportunities. And ultimately, with lithium-ion batteries, we are not at a stage now where we can say that battery management systems are 100% reliable. They can be 99.99, but then you still got to deal with that last little bit of residual. And I guess one of the key concerns there is a lot more concern these days about impacts on the environment from firefighting water and those sort of things. There's been enough issues around, the illegal warehouses of dangerous goods where they've had to fight fires and the resulting contamination getting into creeks and things and killing off wildlife and killing off flora as well, aquatic flora, that they are now saying, well, when you're designing something, you've actually got to be able to contain that fire water. And so you actually got to have some fairly robust thinking about how much would it actually take to control these worst case scenarios, and therefore how much water you contain. So there are new influences that are happening in time, and the scenarios are changing as they're starting to deal with new factors.
I think we're going to see that more and more prevalent as well, because while these, it doesn't matter which like supplier of lithium ion batteries you're talking about. Everyone's searching for performance when it comes to like the characteristics of the lithium ion battery. So the technology that they're deploying, whether it's in their battery management system or whether it's in the architecture of the battery itself, they're always pushing that architecture envelope more and more to get that capacity, to get that performance measurement, that metric out of it. So once we've gotten to a point where we've leveled off, we've tapered off, we can't really exceed the performance boundaries of this technology, then it's probably a case of going, well, this is how we can provide a standardized measured approach against this. And that time, I don't see myself personally, I don't see us entering into that time horizon for probably another 3 to 5 years. So everything's going to have to be a first principle approach around the management, around around the safe handling, the safe storage, the safe use, the safe emergency response requirements for it. It's not going to be like a one size fit all.
Well, I mean, it is. I mean, if you're in Victoria, you've now got to do a fire safety. If you've got lithium-ion batteries or you've got large stores of diesel, you've now got to do a fire safety study as part of your application for written advice.
Yeah.
So effectively, the fire service or the dangerous goods section of FRV is now driving you into that scenario anyway. And effectively, New South Wales is doing the same thing through the PHA process.
And that's still a case by case. Like that's still a case by case. It's not like, as we said, you can't open the stand and go, well, I've got this, I've got that, therefore I can implement this, or I can do this, or I can do that, and then that's going to be my solution. It's a case of engaging at the right time before you build it, or before you modify your building to accommodate for that requirement, to get all your ducks in a line and make sure that it's done as well. So another topic that within renewables, hydrogen, how do you see that space?
Okay. Well, ARUP's been involved in a lot of the preliminary work that went on around advising governments and advising the whole hydrogen space. So that's allowed us to sort of be starting to get involved with, I guess, entrepreneurs and other people who are starting to develop ideas about how they're actually going to take advantage of those hubs and where the opportunities might be, particularly for an export-orientated type process. We are now starting to move, well, that advisory piece is largely done and dusted these days. I think they're pretty much set up where all of that stuff's going. So we are now getting involved, certainly in pre-feed studies, and we have got one project that's heading towards feed that we're working in. So at this stage, it's still very much in the open exactly how these things will develop. When I'm talking about large scale one, where we're talking about ultimately having ammonia or some other hydrogen vector for export.
Mm-hmm.
They're largely ideas on paper at this point in time, and how exactly that would manifest itself in developing safety cases for those sorts of facilities is still going to be very bespoke to a given project and what individual companies are actually doing when they're consulting into these things. So we're going through that same process with individual projects as we speak. So we sort of don't know how that's going to play out just yet.
I think it comes down, I've spoken to a couple of people, obviously, in the hydrogen space. One of the main concerns is like the levelized cost of hydrogen, because the energy cost is one of the main factors or contributing factors to get it to a viable commercial product. And I think if people realise that it's more a percentage towards a net zero than a magic pill of net zero. Why are you laughing with that one?
I'm laughing at that one because it's one of my pet bugbears, is that the cost of hydrogen or any other energy vector that we want to talk about is always always forgets the fact that the fossil fuels have this cost that we don't actually bear, which is the cost of the carbon going to the atmosphere and the climate change happening.
Yes.
We don't pay for that, and they somehow magically think because we're dealing with that issue that the hydrogen should be able to compare itself with the fossil fuel cost of the energy. And you're going, that it's unfair because we're not paying for that cost. If we suddenly built in all the insurance costs for all the flood damage that we're occurring, all the drought damage that we're, that governments have to pay out to farmers to subsidise them to get through those sorts of periods, we started factoring in some of those things into the cost of the fossil fuels. We would start to be getting to some form of parity. And that's the problem that we've got, is we're not factoring those things in.
That's a really interesting point. I've never heard anyone actually talk about that. I've heard a lot of people, and I've spoken to a lot of people and read a lot of reports about the levelized cost of hydrogen, but they've never actually been able to articulate that there is missing input data to support a more normalized like-for-like comparison. So if you putting in a hypothetical, if you took those factors in, what would be, you would see it more a viable. When we talk about viability as well, there's also portions around the infrastructure that supports it as well. So, say 2 years ago, 3 years ago, there was a lot of uptake for hydrogen projects. It seemed like every single business was doing some form of feasibility study towards hydrogen development, towards their net zero targets, integrating that into their workflows. And what I've seen, and you can correct me if I'm wrong, we've seen a bit of a tail off or a bit of a stall around transitioning from all of those preliminary feasibilities into feed and then also into D&C. So is it a case, and from your perspective, is it a case because the infrastructure's not there, because the cost isn't viable, because we're looking at the wrong data, because it's not telling the whole portion, because technologies, or is it a myriad of those reasons because based on the application?
Yeah, I think it's all of those reasons. I think the infrastructure thing is a significant issue. I think the initial projects that might start to, we're caught up in a chicken and egg situation. We haven't got the hydrogen or the ammonia available in the large quantities that we're talking about to start getting, cost effectiveness in the way that those things get produced. So we haven't got that pressure that's helping to bring the cost of all of that stuff to come down. But then we don't have the offtake to be able to come from it. So unless the offtake, the obvious offtake for ammonia is to turn it into fertilizer. So if we can make green fertilizer as being the first option, to me that is one way forward. I think the one that I'm now starting to see in sort of economic articles and things in the paper and that sort of thing is that you're starting to build the green hydrogen actually into the manufactured products. So making green steel, making green fertilizer. To me, that actually makes sense, so that we actually are using that electricity and we're using that hydrogen in its raw state, where we're not actually building in all of that extra energy cost to convert it to ammonia. There is a lot of cost in doing that, and then there's a lot of cost converting it, putting it through another electrolyzer and splitting up the ammonia to get the hydrogen out the other end. It's just a real hassle. And I think the only long-term use for fuel is maybe for shipping. That's probably the big use for ammonia. And then we've still got the issue about how we're going to bunker it and where we're going to store it in port facilities and that sort of thing, to be able to make that viable without causing too much risk to the society that's going to be around it.
What's your idea? What's your commentary on steam reformers for waste management sites? So utilization of
Yeah.
of head stock from like landfill sites to put into a steam reformer to go and reprocess that, basically incinerating it and putting it back to town gas synth gas.
Well, I mean, at one level I go, well, we're not actually solving the carbon problem by doing that. But then you look at it from the other side of it. Well, if you don't utilize it in that way, the methane just escapes the atmosphere and is worse than carbon dioxide anyway in the atmosphere. So you sort of go, well, there is a benefit in actually extracting that piece of energy that otherwise would get lost in the system. So from a philosophical viewpoint, I think it actually is a positive, but I wouldn't be going around artificially manufacturing those sorts of operations to be able to do that. I do see some benefits in waste to energy sort of type systems where directly we start dealing with the landfill sort of type operations, and we stop using, or we start minimizing the amount of landfill and stuff that we use by direct incinerating and therefore extracting the energy that way. So I do see some benefits in those sort of things. Got to keep in mind I've actually worked on 3 or 4 projects related to that for Australia that seem to forever not quite get approved.
What do you think what do you think the challenge is for projects for approval? Like we've been involved with some large scale PEMs that at the start of it they're yep, this is going ahead, this is we're going to drop 10,000, they had their like 10,000 units. They were going to drop them in, series them all up, and start producing hydrogen at large scale. And then all of a sudden, they're like, "No, this isn't getting approved because of X, Y, Z." What are you hearing are the major hurdles for the industry when trying to get these projects approved and over the line?
What I'm hearing, it's really about the offtake. Where are they actually going to send it? Who's going to buy the stuff? Because if you haven't got a market for it, then you can't sell it. So therefore, you don't get the benefits from it. So and it's very much a chicken and egg. The market's not developing because they haven't got the supply to actually feed it. So, like I said, I think it really is only going to be that when we actually start getting a large scale downstream manufacturing operation that actually will consume it, that will tie these two pieces together. Someone commits, I'm going to make green steel, I'm going to make green aluminium, or I'm going to make what's another one? Green cement, for example. Yeah. Unless you're getting one of those things that really commit to it, and they think they can get a benefit out of the added cost that's going to be associated with it. They can put a green premium on their product, and that gets tied up with a facility that can produce large scale. It's to actually feed. I haven't done the numbers or a mass balance to try and work it out, but I can expect that in today's scale, you probably need 2 or 3 solar farms and a couple of wind farms to be able to meet, a steel operation like operates at Whyalla or operates in not Newcastle, in Whyalla, Whyalla and Wollongong. You need fairly substantial sort of backup. So then you've got to get the transmission capability of actually getting the product there and that sort of thing.
Oh, but you've also got to get the physical scale in as well. Like you're talking about an energy consumption cost for that would be huge. Large scale PV farms, large scale electrolyzers, all of that to be able to deal with incoming demand for that particular site. So it's
but I think the technology is there to do. The technology is there, and the land is here in Australia to do that. So that side of the equation is pretty much done. We still got to be able to transmit it, either move the electrons or move the hydrogen that you produce. You still got to be able to move that under a scale that currently is not there. Or you move the steel operation. You know, Whyalla is a classic example. Whyalla, if a place is going to do it, it's going to be Whyalla. It's isolated. It's out on its own. There's nearby solar and wind capability to be able to put stuff up. To me, if you're going to do it, you do it at Whyalla. Because, yeah, it's isolated enough and it's got good resources around it that it could utilize it.
You guys approached?
I can't comment.
Right, boys, this is what we're doing. That time. Well, it's been a really interesting discussion. We've just clicked over the hour, and we typically try and have these wrapped up in an hour. So, any closing thoughts? Any closing commentary?
Well, I guess my closing commentary is, I guess I've enjoyed the career that I've had. So, it's taken me from manufacturing operations through to dealing with some fairly fundamental issues within the built environment, and then into the new renewable stuff. So, I mean, I've had good fun, and certainly process safety has been something that I've found that I just have a natural bent for, and I've been able to utilize those fundamental principles and helping people do the stuff that they need to get done. So,
excellent. Well, where can people find you if they want to reach out? Like, how do they get in contact with yourself or get in contact with ARUP? Or not?
You can find ARUP on the web. There's some fairly open pages. My email is pretty straightforward. It's nigel.cann@arup.com. It's about as simple as it gets. I'm a fairly active user on LinkedIn. You'll find me on most of the process safety LinkedIn commentary things, particularly around ICME and loss prevention and those sort of things. So you can always find me on LinkedIn. I'm usually making comments 2 or 3 times a day.
We had the boys from RMIT on the other day. So with all their ICME and their safety alert bulletins.
Yeah.
So yeah, they're a great bunch.
Yeah.
But well, we'll put those links in the show notes below. So thank you so much for taking the time out of your day. I know that it's busy this time of year for everyone, and you've had some overseas travel as well. So really appreciate you spending the time, coming and having a chat and sharing your journey in process safety. So thanks, Nigel.
Okay. Thanks, Travis.
Have a great day.
Cheers. Bye.